Good evening. Can you hear me okay? Yes. Awesome. My name again is Dr. Raychelle Burks. And what do you think the most important title on the slide is? Nerd! I am a forensic chemist, and I will say this about CSI Miami, which was one of my favorite shows. Totally wrong. But I loved it so much. And how wrong was it? Well, when I worked in a crime lab, our entire annual budget was half the budget of one episode. It gives you a little bit idea. And again, our labs were never that dark, and we never had sunglasses that cool. Right? But what I want to talk to you about tonight is sleuthing the Avengers in chemistry and why I think the Avengers is the best model for how science should work. Are you ready? All right, let's get into it. So Avengers in STEM, why I think that these two things go together like peanut butter and jelly, like Texas and football. That broke my heart a little because I actually got a PhD from Nebraska. And so I think they're going to revoke my degree now because I just said that. But we're in a different conference now. I'm going to tell them that. So what do I think is important about both the Avengers in STEM and most importantly about forensic chemistry? So anybody in here want to be a forensic chemist or a forensic scientist in any way? If you do, okay, great. The most important thing I think is to be able to observe. Okay? And not just, oh, I'm seeing stuff, but to really critically evaluate what's there, who's there, why it's there, and also what's not there, who's not there, why it's not there. So those types of observations are key when you're doing crime scene work. They're super important in the lab. You should always be noting observations. And if you're a scientist, being a critical analysis, being able to have that critical analysis and adductive and deductive reasoning is really, really key to be able to observe really closely. You also have to be able to create. So how many people love to cook? Okay, awesome, you are a creator. Anyone like to do a little DIY around the house? Notice I didn't say do it well, caveat. Okay. So being creative. And that can be in little ways, it can be in big ways. And a lot of the time in science and in Avengers, it's not the big ways, it's a series of small ways that are going to be key. Teamwork. I cannot stress this enough. As we've seen with the Avengers, if you don't have good teamwork, what happens? Okay? So teamwork can go really bad, but teamwork can also go great, and you can save an entire planet, an entire galaxy, an entire universe. The same goes for STEM. You've got to have good teamwork. I do not work alone. I work in a team, and I work in several teams. So that teamwork is critical, and we'll talk about why I think that's so tonight and why it's key in science and in STEM. This is my mystery category. Bit of a mystery, Re. You've got to have Re. Okay? Not the person, although they're critical too. Could also need to have Re. But I'm going to go in, this is my surprise category, and I'll go into this a little bit. What I mean about that Re is really important, and we'll get into that in a bit. And you know what is also very important? You got to have fun. Fun! Okay? You got to have fun. Okay? The Avengers have fun while they're saving the world, while they're saving each other, and scientists have fun. It's not every day sometimes, I'll be honest, okay? But overall, fun is important. And you know what? Some days, it might just come down to your job's just fun and you love it. And you know what? That is good enough, okay? So remember, I said observe was really the critical, key, most important thing, right? Okay. So I am now going to show you perhaps the most important science video you will ever see. Okay. It's a bold claim, I know. But here's what I'm going to need you to do. I need you, again, to think about, I need you to observe, to see what's there, who's there, what's happening. Also important, who's not there, okay? What are you not also seeing? I want you to really think critically about what's about to be on the screen, because we are going to get into the science of it, and I'm going to need your help. Are you ready? Let's do it.
That's enough. Now, I don't know what you plan on doing here.
I've come here to put an end to Loki's schemes.
Then prove it. Put that hammer down.
Yeah, no. Bad call. He loves his hammer.
You want me to put the hammer down?
Are we done here?
All right, so some important things that we saw. Okay. Who was there? That's going to be key. So who was there? Captain America? Iron Man? Thor. Okay. Those are the three that you saw. Okay. What were some important things that were there? Thor's hammer? Captain America's shield? Iron Man's little kind of VI interface, okay? Okay, so what I want you to do now, because again, we work in teams, just talk to the people around you and think about, hey, what were some contextual clues, as I would call them, about what happened in that scene, and what do you think the science is? So I'm gonna give you a minute or two to talk to the people amongst yourselves and kind of talk about what you saw, what you didn't see. I'm hearing some great discussion. Very lively. I love it. I love it. So I'm going to share with you some things that I saw. Okay? And let's see, think about the things that you saw, that you heard from your colleagues, and say, hey, I think she saw what I saw, or maybe she missed something. So this right here really got me. Did that get anybody else? Okay. So here's a few things that I found really interesting, okay? So a little background, if you don't know this about the cap shield, is that it is not 100% stainless steel. If it was, that would be bad news bears. It would get really, really hot, okay? And that's not good. We've never seen it melt. I mean, I've never seen the cap shield melt, so it's not that, okay? And steel is mostly iron with a bit of carbon, sometimes some other elements thrown in, so we've got a periodic table over there. All the stuff in the middle, sometimes we sprinkle it in, just a soupçon amount, okay? To kind of change some of the properties. But Captain America's shield, that's not the only thing it has in it, okay? It's got something else. Does anybody maybe know? I'm gonna go over here because I've been hitting this crowd, so what do we think? Right there. Vibranium, okay? Vibranium. Okay. Now, it's described in a lot of ways in the Marvel universe. Some people say it's an element. Some folks say it's a mineral that's found in an ore, and we mine it, right? And by we, I mean Wakanda forever. But it's definitely in the cap shield, and it's got some interesting properties, because what caught my eye and what caught your eye is what is happening right here. So what we're seeing is Thor's hammer, which is mystical, magical, right? So it strikes it, and what's happening? So if we look really closely, do you see what looks like lightning bolts? Okay, and then kind of a bluish white light, okay? So as soon as I saw that, and yes, I did look at it frame by frame because I'm a nerd, okay? As soon as I saw that, and I know my fellow scientists especially physicists and material scientists, as soon as they saw that, they went triboluminescence. Okay? What is that? Well, so we know it's a vibranium alloy, but let me tell you this other cool feature. So vibranium is said to be a metal, or it could be a metal complex or something like that, a mineral in its mineral form. There's a lot of arguments about that. But let me show you another metal in a complex that has a very similar property. It's a copper complex. So copper, smack dab in the periodic table. Okay? And this is one of our highest tech scientific instruments, a blender. Okay? And triboluminescence is this compound, which it's got this formula. So, you know, we like our very long formulas. Okay? And it's kind of got a cool structure. Okay? This is the structure of this compound. Okay? I like to imagine it has wings. Okay? Now, this forms a crystal, but the crystal is not symmetrically shaped. So it's not even when you split it down the middle. It looks a little bit different on one side than the other. And the cool thing about that is that when you hit it, it actually causes, in a complex reaction, it causes that electricity you saw. Okay? It looked like a lightning bolt. Okay? The even cooler thing is that there are molecules in the air, typically nitrogen, because it's a lot of nitrogen in our air, that actually gets those electrons. The nitrogen itself gets excited. Okay? Imagine your mom waking you up at 6 a.m. You're excited. Okay, how many people are not excited when their mom? I wasn't excited when my mom woke me up. So what do you want to do if your mom wakes you up at 6 a.m.? Go back to sleep. You want to relax. Well, so does nitrogen. And when nitrogen relaxes, it kicks out light. And we see this beautiful UV color. Well, sometimes other things can absorb that light, and we'll see even funner colors. And that whole process is called triboluminescence. And the whole thing is kicked off by just hitting it. So imagine with Thor's hammer and that shield, that would really set off that reaction, right? Okay. Now, do you need to have vibranium in order to see this? Well, no, because we've already seen an example. Okay? But I want to show you another example that is super cheap, super easy. You're actually going to get some for home. And it's delicious. Okay. And it'll make your breath minty fresh, which your friends will like. Okay. So lifesavers, and it's only these lifesavers. What's so special about these ones? Well, it's the mint, not just the mint. It's actually wintergreen, oil of wintergreen. Okay, technically not a mint, but it smells minty, it tastes minty. Cooler thing is, of course, lifesavers, what we like about them too is chock full of sugar, right? Sugar is a nice crystal, and guess what? It's very much like the other crystal I talked about that is not symmetric. When you hit it, it starts off that cascade with nitrogen in the air. Same excitation and releasing of light because nitrogen, like us, does not like to get up at 6 a.m. Okay. Now, the cool thing about these particular lifesavers is that they contain methyl salicylate. Now, this compound absorbs that light and then itself gets excited, relaxes, releases light. The cool thing is it releases light in the area that we can see. Okay? So that means that you could be crunching lifesavers and seeing light right there in the mirror. Okay? Let's see what it looks like. You see? Let's watch it again. Yeah? Could be Thor's hammer on the shield. Could be Thor's hammer on a lifesaver. Lifesaver, Captain America's shield. Same thing. So basically, Captain America's shield and a lifesaver, they're the same. Okay? They're not the same. Please do not get in a fight with a lifesaver. Don't get in a fight in general, but don't get into one with Thor with a lifesaver. Okay? Now, where can we shop for a lifesaver? Well, like anywhere, right? Okay. If I want vibranium, however, where do I have to shop? Wakanda! Right? We got to go to Wakanda. Now, Wakanda is this great, it is a fictional country, but the best thing about Wakanda, especially on the Black Panther movie, is that it highlights some of the amazing science going on in several different African countries. And we look at Wakanda and we see that there's a lot of science going on, right? We've got a lot of creation happening in Wakanda, and most of the time it's Princess Sarie, right? She is top scientist. In fact, her official title is Chief Scientific Officer of Wakanda. Okay? So Princess Sarie, of course, she's a whiz at material science and textiles. She's whipping up Black Panther suits like it's no big deal. She's also in charge of the entire transportation system, which depends on vibranium as well. She makes cool arm rockets, which I'd like to have sometimes. Okay, so that, but also, it's also used to heal. So vibranium plays a key role in their medical facilities. This is a little bit of that teaser clip that we saw at the end of Black Panther. Okay? So there's a lot going on. And there's a lot of creation in Wakanda. And who, again, is behind all that? Sarie. Okay? She plays a pivotal role in the advancement, the innovation, and the creativity of Wakanda. Okay? She plays a key role. And who does she work most closely with? Black Panther, T'Challa, King of Wakanda. Okay? She has a pivotal role to play. Okay? And he listens to her, right? Because she knows what she's talking about. How does he know that she knows what she's talking about, right? Well, the good news too is that according again to the lore of the Marvel Universe, that Black Panther also has a PhD. In his spare time, he earned a PhD in physics from Oxford, when he wasn't being Black Panther or King of Wakanda. Which makes me feel really lazy, but okay. The key thing with teamwork too is that you've got to work together as a team, but you've got to have good leadership. Okay. So I lead a research team, and you know what the most important decision I make in a team is to hire the best people. People that are, I hope, actually, more talented than I am, smarter than I am, more ambitious than I am. You want to bring in the best, or you want to train up people with really high potential that can exceed your wildest dreams and their own dreams for each other. Right? You've got to have that as a leader. The cool thing too about Black Panther again is he and his chief scientific officer have this great relationship, total trust in each other. They work great as a team. They have that teamwork element, which is so key. It's a good model for how we should be with people who have different roles. Okay? So if you've seen the movie, you know that Princess Sarie's role and Black Panther's role are different. But they both make significant contributions, and the whole endeavor couldn't be successful without the both of them. They are bringing something amazing to the table. Now, even though he's the king of Wakanda and he's the leader, she has a leadership role, she is contributing, and they both come together in this really powerful way. And that is how the best STEM projects work. They've been team-driven. It's been a huge collection of really motivated people that work together well. And, of course, it helps that they're smart. Okay? But what's also more important, anybody who works in a team, I hope will share this with you, is that they work well together, they want to make it work. They want to bring out the best in their colleagues. And we see that definitely in Black Panther. Speaking of teamwork, how many people are familiar with Monica Rambeau? No? Well, I'm going to dazzle you, okay, I hope. Monica Rambeau is my favorite Avenger, but how many people knew she was an Avenger? Few people. I'm only seeing a few hands. So Monica Rambeau has several titles, one of which is she's actually the original Captain Marvel, about 30 years ago. That's way before Carol Danvers was just named. Okay? And another cool fact, I don't know if you know this, but she was actually nominated by Captain America to be head of the Avengers, and she was. So great leadership abilities. So I really admire that as someone who has to supervise people, or I should say gets to supervise people. I really admire her leadership abilities. And not only that, but she was recognized as a leader by her peers. She was appreciated by her peers for everything that she could do to bring a team together. Because the Avengers, they can be a bit of a challenge as a team to manage. I don't know if you've noticed that from the many scrimmages they seem to be in sometimes. So she was put in charge of them. The other thing I love about Monica Rambeau is I'm a forensic chemist, but I'm also what's called an analytical chemist. So how many people know what an analytical chemist is? Okay, so some people do. Basically, I don't make chemicals. Okay? I find them. Okay? I find very particular chemicals in a sea of other chemicals. And so in order to do that, I have to build cool gadgets. Okay? To do that. And some of the things I build actually are kind of like Monica's superpowers, which is why she's also one of my favorites. So buckle up for this. This is her superpower, and it's cool. Are you ready? Okay. She can change her matter into light. Okay? I'm going to say that again because I didn't hear enough wows. She can change all of her matter into light and back again, and back again, and again, and again, and not lose a finger or an eye or anything. Wow! Now, why would that be useful? Well, how fast does light travel? The speed of light, really, really fast. So that property could be useful, okay? Now, notice the squiggly lines there. Are there different types of light, different colors? Yeah, there's red light. I'm looking right into very bright white lights, okay, which is like kind of a combination of all colors. So is there light we can't see? Sure. Monica can change into them all at will and then change back, depending on what does the situation call for? I might need to be blue, I might need to be red, or I might need to be a microwave. I know! Okay? Maybe I want coffee. Zap it. Okay? She's never done that, but she should. So she can change at will, and then she can change back. That, to me, as someone who works with light and energy to study matter, is really cool, okay, that she can control and has that level of control. And not only that, but she can observe the situation well enough to know which light she should be. And then, boom, she's that. And I think that is an amazing superpower. Now, I want you guys to see the kind of light that we're dealing with. So there should be some diffraction gratings right around you, I hope. You might not know what these are. They look like this, little cards. Okay. So if we could have the lights up. Go ahead and hold it up. You should see a nice rainbow. Does the white light become a rainbow? Yeah. I see purple, blue, green, orange, red, yeah? And if you move it around, you'll see different lines. That is what white light is made of. So imagine being able to change into any of those colors at will, just because you want to. Maybe you want your whole room to be really purple. Okay? And you could just change into purple and then change back into yourself. That sounds super cool. I think it does anyway. We could have the lights down. So the visible range, which is the range you just saw, okay, is really tiny, actually. That's the entire electromagnetic spectrum. We usually show this picture like this. See how small the visible range is? The light you can see? It's very, very tiny. Okay. So Monica can change into all of those, any wavelength she wants. It's not just color, it's any wavelength she wants. So she might want to be a particular color, or she might want to be a radio wave. She's going to look at the situation and decide what she should be. Okay. That is a bananas skills to have, again, because light travels at the speed of light, which means, what if she's trying to help somebody on Asgard? She can be there like, actually faster than that. That was kind of slow. Okay. So she could be there and she can save them. She could travel anywhere in a really fast amount of time and save people. So you can see why they maybe put her in charge of the Avengers, because they tend to get in trouble all over the place, right? So that is a really cool skill. So she is my favorite because she is using a skill I use every day. Okay? And she's got great teamwork. But the other thing I love about Monica is that she reinvents herself all the time. So she's Monica Rambeau. She's been Captain Marvel. She's also changed again and been called Photon, Pulsar, Spectrum. Okay. The cool thing about her is that she is flexible and she will do what needs to be done when it needs to be done. No job is too small. No job is too big. She just gets in there and gets her hands dirty. And that is really important because the next big thing is this re category, the little mystery one. Well, it's not too much of a mystery because I like to tell my research students that we put the re in research. Okay? Because you are going to have to redo it, probably revise it, and you're probably going to have to reinvent it at some point. Okay? Now, these sound like really positive words, right? When we say, oh, someone reinvented themselves, or they redid it, or they did research, these are really positive, right? But what do all of these things require? If you're redoing it, it's because it didn't quite work the first time. Okay? Now, when I think of failure and research, redo, revise, reinvent, and the Avengers, there's only one Avenger I can think of that really nails this category like nobody else. It's got to be Iron Man. Right? Lots of success, we agree? Lots of success? Lots of failure. The two often go hand in hand. Let's talk about it. He's a great inventor. We agree? Okay? Well, the first Iron Man suit, we're talking real old school, was actually made out of iron. It would have been way too heavy and way too hot. So he redid it. And when he redid it, he went with a gold titanium alloy. That sounds really fancy until you realize it weighs even more. And he hasn't gotten any bigger or bulkier. Okay? So that's an issue. Now, it's probably that his suit is made out of a nickel alloy called nitinol. Okay? Much more flexible. It actually has some, quote, self-healing properties, which are really cool. Okay? But he's tinkered with the suit a lot. How many suits does he have? Tons. Does he make suits for other people and tinker with them? Sure. He's always, again, tinkering, redoing, revising, doing research. And that's not the only thing. So he's got that glowing thing in his chest that's keeping him up, right? So when he first did it, it was great. Actually, someone else did it for him, but he's tinkered with it. One slight problem, it was actually slowly poisoning him. Okay? That's not good. Okay? But, again, for a first attempt, it was all right. But he said, you know what, I don't want to be slowly poisoned. Let me tinker with it. Okay? So what did he do? he made a particle collision reactor, okay? Which, hey, that's great. We've made those. They're super. Okay? We don't have any this small, but we, you know. So what did he do? He made his own element. Well, that's okay, because we have a lot of those too. All the really cool ones that are now towards the bottom of the table, we've made a lot of those. Okay? Now, again, in a maybe not chess portable, okay? But maybe we're getting there. But he's tinkered with these things, and he's reinvented himself over and over again, and tinkered with his toys and his tools to try to make things better. Okay? Didn't give up. He just kept showing up, okay, to do the work. So I really look to him because, you know, some things just you're like, ooh, I don't think that's going to work. It didn't work, but he just got back in there. And then, what do we remember? We tend to remember all the cool stuff that works, right? We remember at the end of the line is what we tend to remember. Okay? So I like this quote from another aerospace scientist, which is Abdul Kaman, who was also president of India. And if you look at it this way, I think it's really great, because he says, if you fail, never give up, because fail means first attempt in learning. That seems more like an Avengers creed. Okay? The end is not the end. In fact, end means effort never dies. Okay? That's more of an Avengers mentality. That's what we see. And that's also what keeps you going back to your research in the lab, or what keeps you tinkering with that DIY, right? Is that maybe your first attempt didn't work, but I'm going to keep at it. I'm going to keep gaining. I'm going to keep creating. And eventually you will create something. Okay? It might be a cool new gadget, or it might be a groundbreaking idea. Okay? But keep at it, keep the in research, and you'll get there. Okay? Now, Tony does a lot of cool stuff. Yes, we are on a first name basis. And he does a lot of it, of course, for the pure science of it. Okay? He also likes to help people. Okay? I think he feels a bit guilty about that whole weapons thing. Okay? Might be some dad issues. I don't know. He's got a lot going on. Okay? But I do know this, too, about Tony, my good friend. He also does it because it's just fun. Okay? Of all the Avengers, sometimes it seems as if he's having the most fun. Okay? Now, I have a question for you. Is science fun? Thor would agree with you. Science is fun. And why is it fun? Well, there's a lot of reasons for that. But sometimes, because you work with cool people. Okay? Like whether it's the fictional Banner or the real Banner. Okay? You can have a lot of fun at work. Okay? I work with some great students and great fellow faculty members. And sometimes, I'll let you in on a secret about science. Sometimes it's actually a little boring. I know, it is. That was my face too. Okay. Sometimes when you're doing all that stuff, the research, the revision, the redo, okay, collecting all that data, doing things 10 times, 20 times. I'm analytical, 1,000 times. Okay. That part, I'll be honest, can be boring. But what's made it, the days seem short, is I work with really cool people. And I get to talk to really cool people. So sometimes that gets you through those boring days. And sometimes science isn't just boring, sometimes it's excruciatingly difficult. You can't crack this problem, you're just not sure what the answer is. Well, what keeps you coming back? Sometimes it's just your pure love for it and your passion, and sometimes it's that colleague that just gives you the good motivation. And that's why teamwork is critical, because sometimes the team can keep you going. Have we seen that with the Avengers, where one of them was tired or fed up or frustrated, or maybe a lot of them were, and somebody just said the right thing to keep them going, to keep them showing up. And sometimes, too, the fun of working with the team helps you get even more cool science done. So one of the funnest things I did this last year was I got to play my own Nick Fury. I actually dressed my dog up as Nick Fury. So, and afterwards, I'll show you a picture if you really want. I got to do this thing called a superhero hackathon with a couple of my colleagues. So there we are. We're at the Royal Society of Chemistry in London. They have what's called Burlington House. It's very fancy, okay? Or as what they would say is posh. Okay? And it's in this beautiful house, and we gave this whole presentation about let us build a better superhero. Okay? So who was in the room? Well, there's myself, I'm a chemist. There's Dr. Kundu, who is a material scientist and a chemist. Dr. Lee, who's a biologist and specifically a mammologist, because if we're building a superhero, we're gonna need some biology too, right? Okay? And then so also in the room were tons of other scientists and people of all ages that weren't scientists. Some folks were lawyers, some folks were graphic artists. It was a really great eclectic mix, and everybody contributed something awesome. Right? Because the team is key. Different viewpoints are key. Different experiences. They're going to have different suggestions. And you see that drawing that's behind us? So that artist was actually drawing us a superhero while we were talking about how to build a better superhero. Okay? So the audience decided how to build a superhero based on, well, what are our goals? What are we going to want this superhero to be able to do? Okay? And what we came up with is Delta Gene. So you can tell we had a really mixed set of experts in the room because we had a whole scientist who did research on cephalopods, okay? So squid, okay? And they have amazing properties. Have you guys seen that video where a squid like squeezes itself through like a hole that's like crazy small? Okay? So we wanted to be able to do that because that would be a really handy skill. So we've got that. Then we have cyanobacteria because we had a bacteria expert in the audience and they were like, you gotta have this skill. It's gonna be amazing. So then of course we've got Delta Gene because we had lots of chemists in the room and physicists and we're always concerned with thermodynamics, okay, and kinetics. I don't wanna give kinetics a shaft, so we have all kinds of things. We had neuroscientists in the room, so we wanted to talk about how could we possibly get into mind control. Well, that's when the biologist, specifically working with fungi, was like, I got you. Because there's this one type of fungal infection that does kooky things to people's brains and different species' brains, so let's get on it. So we have all kinds of expertise here. And then we came up with this awesome name, Delta Gene. It was so fun. We had the best time doing this. And you know what we did? I learned something, because I'm a chemist. Okay? I'm not a biologist. Don't ask me to keep stuff alive. Okay? I'm a forensic chemist, so you know I'm not keeping anything alive. But I learned so much about gene editing, and we wanted to be able to do that. And then there's also some features about birds in there. I learned more, too, about material science and the physics of that. So not only was I sharing my knowledge, but I was also learning from my colleagues. We were creating something. We were working together as a team, and we had so much fun. Okay. So I'm going to leave you with some homework because I'm a professor and I'm contractually obligated to do that. Okay. I want you to think about this cycle again, that you have to really observe, that you want to be creative. You want to work as a team. You want to revisit, revise. You want to do research. Okay? You want to reinvent, and you want to have fun. Okay? Do you know something in your life that, gosh, you wish this did something different, or you wish you could fix something, and you just don't know how? But if you just dream about how you could fix it maybe, or how you could explain it. Okay? So I want you to observe, and I want you to dream. The wildest scheme that you can come up with. That's what we did at the RSC. We just thought about what are some problems we'd like to solve, and how would we possibly solve them if there were no limits? If we could dream big, big, and of course with bacteria, small, small. Okay? So your homework is to think of all of that, because I know you can do this, because we have a lot of creative, observant, fun people in the room. Your own superhero should go here. Okay? Anything you want, as big as you want, as talented as you want, as small as you want. Okay? Build it to fit your life, your needs, or maybe sometimes we do it because it helps someone else. What is the problem that you think needs to be solved, and what superhero could you make that would do it?